everyone, so in this lesson we're going to be looking at the square root function and also reviewing those transformation rules that we did with the absolute value function. Okay, so first thing I want to do is I just want to review the rules. Okay, so you should already have this in your notes. If you don't, you can certainly write it down again, and it's not a bad idea to have these notes out in front of you throughout the lesson. All right, so these are the rules for translating, scaling, and reflecting functions. So when you add a value at the end of the equation, that's when you're going to shift up that number of units. So here we're shifting up C units. All right, when I subtract a number at the end of the equation, that's when we're going to shift down C units. Okay, when you add a number inside the function's argument, so that would be like inside the absolute value symbols, that's when you shift left. Okay, when you subtract a number inside the function's argument, you're shifting to the right. Okay, when you multiply by a negative, that's when you reflect over the x-axis. Okay, when you multiply by a number greater than 1, we call that a vertical stretch. Okay, so that's when the points get closer to the y-axis. Okay, so that's when your graph gets skinnier. All right, when you multiply by a number greater than 0 but less than 1, so by a decimal or a fraction, we call that a vertical compression. Okay, so in a vertical compression, the points move further away from the y-axis. So that was just a review of all the transformation rules we've gone over so far. And again, if you forget any of these, you can easily verify them with the calculator. Okay? So now we're going to take a look at the square root function. So we want to graph f of x equals the square root of x using a table of values. All right, and you'll see here that we do have a restricted domain. They want us to graph the interval from 0 to 6. Okay, so we're going to go to our calculator, go to y equals, and to get that square root symbol, you hit second, and then the x squared button. Okay, so the square root of x, then I'm going to go to second graph to access my table, and we're going to copy all the values from 0 to 6. Okay, so I'm just going to copy these values right onto my paper. Okay, so 0 is 0. 1 is 1, 2 is 1.4142, 3 is 1.7321, 4 is 2, 5 is 2.2361, and 6 is 2.4495. Okay, so one suggestion I have when you go to graph this, sometimes it's nice to graph the integer values first. Okay, so we got the 0.00, right? That's a nice point to graph. The 0.11 and the 0.42. Okay, this way you kind of get an idea of where the points are heading, and then you can go back and fill in the rest. So when x is 2, we're at 1.4, so that's a little bit higher. Then we go to approximately 1.7. All right, at 5 we go to 2.2, so we're a little bit higher, and then 2.4. Okay, so my graph is going to look something like that. All right, and I'm not including arrows because they did give us a specific interval to graph. Okay, and if we put this on the calculator screen, we'll see that our graph looks the same, right? So I call this the hook graph, right? It sort of looks like a hook. Okay, so here our domain is just going to be the interval I gave us, right? So we're going from 0 to 6. Those are the x values. And then our y values go from 0 to 2.4495. Okay, so that's the graph for the square root of x. Okay, so now in number 2, it says based on the graph that we just did, based on that parent graph, sketch a graph of g of x equals the square root of x minus 5. Remember your rules for transformations. Okay, so here we're subtracting 5 inside the function's argument, right? We're underneath the radical symbol. So if I go back to my rules, when I subtract a number inside the function's argument, that means we're shifting to the right. Okay, so in this example, we want to shift to the right 5 units. So we're going to take this graph up here, and we're going to move it 5 units to the right. Okay. So this is going to be a shift right 5. Okay, now when they say sketch, they're not looking for a precise, accurate graph. A sketch is kind of just an approximation. So all I need to see on your paper is that you show you're shifting 5 units to the right. Okay, that's what a sketch would look like. Okay, and again, what's really nice about questions like this, we can verify it with our calculator. So if I go back to y equals, and now in y2, I type in the square root of x minus 5, and I hit graph, all right, you'll see it's the same graph, we're just moving it over 5 units to the right. Okay? All right, so my domain. So remember, domain is all x values, how far left and how far right your graph goes. So here we're going all the way to the right, but my x values begin at 5. So my domain is going to be x is greater than or equal to 5. All right, your range is your y values. All right, kind of like being on an elevator, how high and how low your graph goes. So this keeps going to the right, but it also slightly keeps getting higher and higher and higher. So the minimum y value we have is 0. So our range is all values where y is greater than or equal to 0. Okay, let's try another one. Based on the graph of f of x equals the square root of x, sketch a graph for h of x equals the square root of x plus 6. All right, so you'll notice here the plus 6 is outside of the square root symbol, right? It's not underneath the square root. So if I go back to my rules for transformations, when you add a number at the end, you're shifting up that number of units. So this is going to be the square root of x shifted up 6 units. Okay, so again, it's just a sketch. So I'm going to do 6 little marks on my graph. And then I'm going to draw that square root of x curve. Okay? And again, what's really nice is that if you're not sure, just go back to your calculator. Okay, so this time in y2, I'm going to type in the square root of x plus 6. Okay, so this is the square root of x, and this is the square root of x plus 6. So you'll see it's that same curve, it's just shifted up 6 units. Okay, so again, domain is how far left and how far right your graph goes. So our x values are beginning at 0, so it's x is greater than or equal to 0. And here, the minimum y value is 6. So this is going to be y is greater than or equal to 6. Okay? All right. Oops. So in the next set of questions, it says write the equation for each graph. Okay. So number 4, first thing that you should notice is that my graph takes on that V shape. Okay, so hopefully from last week you remember that this represents the absolute value function, right? Absolute value takes on that V shape. So this is an absolute value graph. All right, so typically an absolute value graph looks like this. So it looks like what happened here was I shifted left 3 and down 4, right? That's how they're getting the vertex, -3, -4. So we shifted left 3 and down 4. Okay, so my equation, to go down 4, we subtract 4 at the end, and to shift left 3, we're going to add 3 inside the function's argument. So you should have x plus 3 inside of those absolute value bars. Okay? Number 5, okay, so you should recognize based on the shape that this is the square root function. Okay, so here we know that the square root function, the parent graph, looks like this, right? So here we're shifting left 1 and down 2. Okay, so to shift down 2, we're going to subtract 2 at the end. And then to shift left 1, we add 1 inside the function's argument. So that plus 1 has to go underneath the radical symbol. Okay, the -2 gets left at the end. All right, so the next set of questions in the handout are just review questions. So what I'll do is I will definitely post the answer key so that you guys can take a look at some of those and try them on your own. All right, hope this was helpful. If you have any questions, you guys can always email us or send us a message on Google Classroom.